Good morning, good afternoon, good evening, everyone. My name is Vasily Smolyanitsky. I'm working for the Arctic and Antarctic Research Institute, and I'm going to present you a report summarizing lessons, knowledge, perspectives which we gained by supporting a network of different buoys in Eurasian Arctic for the benefits of your project. That is a collaborative report by me and my colleagues who contributed a lot for logistics of these activities, or just manufacture of the buoys and extending their capabilities, or analyzing their behavior in different environmental conditions. In a total, we installed 41 buoy in Eurasian Arctic, and by supporting of this network, we gained actually a new knowledge of environmental conditions, and as well as gained knowledge of logistics of buoys deployment and their behavior and lifespan. New features of environmental conditions included, for example, such things as patterns of coastal drift in Eurasian Arctic seas, which I underlined by red circles on the figure on the left. And for example, one of the buoy drifted along the coast for several hundreds of days, and that was similar to 1970s, 1980s, but what was opposite actually to early 2000s. Then just on the central part, you can see a buoy which drifted very slow, and even actually much slower than Polarstern, and but in the region nearby. By red colors, I underlined record and record lifespans of the buoys, and record lifespan was more than 120 days for the buoy, which actually worked most of its time on Victoria Island. And for the buoy in the high sea, that was 431 days, and this trajectory is marked by violet. And on average, the lifespan was 221 days, and medium was 190 days, and anti-record was just 2 days. And to deploy the buoys, we used all available techniques, starting with helicopters, and then just expeditionary vessels from my institute, or just icebreakers. On this slide, you can see all statistics for all buoys, starting from platform IDs, WMO IDs, deployment date, and deployment coordinates, and coordinates at the end of lifespan of the buoy, and type of the buoy, etc., etc. And we analyzed drifting trajectories of all buoys, and as a result, we got the following conclusion: that lifespan of the buoy and performance of the centers depends actually on the duration of homogeneous conditions, whether the buoy is on clear water or sits on the ice, or actually driving ashore, and occurrence of unpredictable external influences like icebergs driving at the ice edge, etc., etc. And on the right, you can see the buoy which provided us anti-record, just 2 days, again just, and possibly broken by iceberg beat. But as we didn't had additional information from the sensors of the inside the buoy hull, we were not completely sure what was the reason of the buoy breakage. And in homogeneous conditions, the buoy can exist for more than 3 years. During YOPP period, we were close to optimal density of an observational network in Eurasian Arctic, but further in last year and this year, the network density again just was degraded for the high seas mostly, of course. And on the left you can see a network of coastal stations and in the Eurasian Arctic, and you can see that from the point of the requirements, WMO requirements to shipborne, that's more or less okay with the coastal stations. On the right, on the top, you can see the different buoys by August this year from the International Arctic Buoy Program, and most of the buoys are concentrated in Canadian sector, American sector, and some are near Greenland or just Norway, and practically no buoys in the Eurasian Arctic. And it is, of course, partly due to degradation of logistics, but as well as there are environmental factors, like just when buoys are deployed in Eurasian Arctic, they are quickly involved in the trans-Arctic drift, and that is opposite to the buoys for in American sector. And on the bottom you can see density of voluntary observing ships observations, and this pattern is opposite to the different buoys. Most of the observations are along the Northern Sea route, and practically no observations are in Canadian sector, but again just density of observations is far from optimal. So main incentive from YOPP period. YOPP period provided us possibility to develop concept and develop a schema of network development during the next 3 years and further in time. Network in general will be based on ice-strengthened buoys with the basic manufacturer Martin-Hughes, and all buoys will have basic periodicity of 1 hour between observations, and backbone of network will be a barometric ice SVPB buoy that is installed at the centers of 500 km circles, thus following shipborne requirements, and at additional points, centers of 200 km circles, there will be thermoprofiling buoys of ice BTC types with strings from 1 meter to 80 meters. In a total up to 40 buoys, and most of the buoys will have the WMO identifiers and will be available through the WMO GTS or WIGOS. And gradually we plan to equip the buoy with additional sensors inside the hull, so that we'll have more information about the external factors controlling the lifespan of the buoy. Basic types of the buoys: barometric buoys A, oceanographic buoys B, with the strings up to 80 meters, snow ice thermoprofiling buoys with strings up to 5 meters, and special buoy for to measure snow ice heat exchange with a string of 1 meter and 10 centimeters. Some sample products from the thermoprofiling buoys installed at North Pole this July. Information about seasonal variability of heat exchange in the snow ice ocean surface layer, including estimates of sea ice thickness. That is a colorful figure in the center, and information on temperature on different layers. For these buoys there are 10 layers, and of course sea ice dynamics like drift, total drift, and tidal movements. Roadmap is depicted on this figure, and in general this year is dedicated to proposals and technical justification. By the end of this year we are starting test deployments. Next year start of basic installations and purchase of additional instruments. Year 2024, additional research and development aimed to extend functionality lifetime of the buoys. And at the beginning of this year, also target observation density reached. And starting from 2025, formation of a joint network of surface and moored buoys and ice weather stations. So thank you for your attention, and I'm ready to answer your questions.
So Vasily's online and can answer a few questions on that talk. That was actually the talk from Monday.
Yes, thank you, Claire.
While people are thinking of a question, I'll ask, what caused your 2-day anti-record for your buoy deployment? Was that just bad luck or a particular event?
So the answer is just, we don't know. So we are going to install additional sensors inside the hull starting from next year or so, and that will include humidity sensor inside, pressure sensor, and temperature sensor, so that we would know whether there was some impact on the buoy hull or something more just gradual, influence on the buoy. But at the moment, we are not. I'm not ready to answer the questions. Actually, there were some berg beats near the buoy, but the ice edge was at a distance of 30 miles.
Okay, thank you. I think Bruno's got a question.
A very small technical question. Can you repeat the name of the manufacturer for the buoy? It was Marlin.
Marlin YOPP. Marlin YOPP is one of the oldest manufacturers for the Eurasian buoys, and they're providing buoys for the last, I think, 25 years or so, and both for national customers inside Russia and also international customers.
And they are based where?
They're based in Rostov region in Russian south.
Thanks.
And a significant share of the buoys deployed during MOSAiC campaign were produced by Marlin YOPP.
I have a question. Do you lose buoys sometimes when there is a ridge building? I guess so. That's what you meant by homogeneous ice condition, right?
Yeah, of course.
Okay.
The answer is yes. If we have homogeneous conditions, level ice, then the buoy can safely drift from Eurasian Arctic up to Front Strait.
And what about polar bears? You lose buoys from or animals?
I don't think. The buoys are quite small, tiny, and so we had no experience as any cameras will consume a lot of energy. But I think they are of very little interest to the polar bears.
There's just a comment from Helga in the chat who says, Vasily, it's great to see such collaboration still functioning so effectively. This is way more promising with respect to buoy coverage than what one could have hoped for. Great job.
Oh, thank you.
One last question. Is the data from the buoy public?
The answer is yes. In general, in most cases, yes. And for all your buoys had WMO identifiers and were circulated inside the WMO GTS. For the next buoy deployment, some of the buoys will be at WMO GTS, some in WIGAS.
Can we contact you directly to get the data, or it's online?
I aim to publish the data operationally online, but you can contact me if there is a need for additional information.
Okay, thanks.
I cannot promise buffer, but I can promise simple, delimited files.
Okay. Other questions before we move to the next? Well, Vasily's next talk.